Okay, hi geometers, this is Ms. Backfish, and we just talked about Pythagorean theorem in my last video. I'm sure you can find that if you need to go back to that first. And make sure you do understand the Pythagorean theorem first before watching this video, because now we're going sort of backwards. We're going to talk about the Pythagorean converse. Really, that's a sort of short way of saying the converse of the Pythagorean theorem. The converse, remember, of a theorem is basically going backwards. Like, for instance, we had if lines are parallel, lines crossed by a transversal are parallel, then corresponding angles are congruent. The converse would be if corresponding angles are congruent, when lines are crossed by a transversal, then the lines are parallel. So it's just basically going in reverse order. The Pythagorean converse, same idea. When we looked at the Pythagorean theorem, we started out with the assumption that we had a right triangle. And we said, okay, when we have a right triangle, this is true. So this was like our hypothesis. If this is true, if I have a right triangle, this was my conclusion. Then a squared plus b squared equals c squared, or the other leg squared equals the hypotenuse squared. The Pythagorean converse is basically going backwards. It says if we have three sides of a triangle. If A, B, and C are sides of a triangle, or side lengths, really, of a triangle, then squared equals C squared, it must be a right triangle. Makes sense. We're going backwards. So I don't start out knowing it's a right triangle. I start out just knowing I have three random side lengths of a triangle, and I try to fit them into the Pythagorean theorem, and I say, is this a right triangle? Yeah, it is. It works. Now, let's say, how do we do that? How do we fit them into a right, or fit them into the Pythagorean theorem to check to see if we have a right triangle? Okay, so let's suppose we're given three side lengths, and sometimes it's just stated like these are just lengths of three random segments. And we're asked, is this a right triangle or not? First of all, remember that this is leg squared plus leg squared equals hypotenuse squared, and hypotenuse has to be the longest leg, longest side, has to be longer than either of the legs. So C has to be the biggest number. All right, so we always have to check and make sure we see what the biggest number is and make sure we use that as C. So in other words, now we're trying to find out if 2.1 squared plus 7.2 squared equals 7.5 squared. So we check it out. You could probably see already. Here's how I'm going to compare them. First of all, I'm going to do one side of the equation, 2.1 squared plus 7.2 squared. Press enter, and I get 56.25. Then I want to see if that's the same as this side of the equation. So I'm going to do 7.5 squared. And I got 56.25. So yes, those are equal. So yes, this would be a right triangle because a squared plus b squared equals c squared. And by equals, I'm talking about exactly, not rounds to be the same as it, not it's almost the same as it. It has to be exactly the same. Now, the nice thing about the Pythagorean converse is that's not all it tells us. It also tells us what kind of triangle it is if it's not a right triangle. In other words, we go on, okay? And it says, if a squared plus b squared is less than c squared, then this is going to be an obtuse triangle. If a squared plus b squared is larger than c squared, then it's going to be an acute triangle. Now, first of all, remember that, right, obtuse, acute, whenever you have a triangle, you have three angles, and in an acute angle, in an acute triangle, all three of them are less than 90. In a right and an obtuse, you still have two acute angles. It's just that you have one that's right or one that's obtuse. My acute triangle here looks almost, let's pretend that's 88 degrees. And this is, say, 120. Okay, so the other two are always going to be acute anyway. It's just if you have one right angle, it's a right triangle. If you have one angle that's bigger than 90, that's an obtuse triangle. And if all of your angles are less than 90, it's an acute triangle. Now, this is the way you'll see it written in some books. This is not, to me, the easiest way to think of it. And here's why. When I think about less than, that doesn't seem to go with obtuse, because obtuse means bigger than 90. It's the biggest one out of these. And if I see greater than, that doesn't seem to go with acute. So I don't think of it this way. Here's how I think of it. Look at your c squared and use it to compare. All right, base all your decisions on c squared. Here's what I mean. If I am asked to decide whether I have an acute or a right or an obtuse triangle, then I square and add A and B. And then I go and I square C. And then whatever I get here, I make my decision based on this. If it's bigger than these, obtuse. If it's smaller than these, acute. What? Well, because look at this. If I turn this around, this says that c squared is bigger than a squared plus b squared. And this says that c squared is smaller than a squared plus b squared. So if we think of it from the perspective of c squared, then it kind of makes sense in terms of size. Let me give you a couple of examples. Let's suppose that the lengths I'm asked about are 3, 4, and 7. Now remember, you always have to think about which one's the biggest number because that has to be c. Okay, so it is in order this time. C is the last number. It's not always going to be. So these are my A and B. So first I'm going to do 3 squared plus 4 squared, and I'm going to figure out what that is. And that's 25. Then I'm going to come over here and I'm going to say, let's do c squared, and I'm going to figure out what that is. And then I'm going to look at this number to decide. If this number is bigger than this number, which it is, obtuse. If this number was smaller, it would be acute. If this number is the same, it would be right. So because 49 is bigger, c squared is bigger, this is an obtuse triangle. So do everything based on whether c squared is bigger, smaller, or the same as a squared plus b squared. Let's do some more lengths. How about if I have 5, 5, and 5 root 2? Okay, a squared plus b squared. First of all, I have to know which one's biggest. And yes, this one would be biggest. You could put it in your calculator to check. You could stick it in there and say 5 times the square root of 2. Your calculator is going to say same thing, but you can press the button right above enter that changes it to a decimal. So that's about 7. It's a little bigger than 7. So yeah, that's the longest side. You do have to check. So my two shorter sides here are 5 and 5. So that's 5 squared plus 5 squared. 25 plus 25 is 50. And then over here, 5 root 2 squared. Be very careful when you put that in the calculator. If I put it in the calculator like this, it's wrong. The reason that's wrong is because what my calculator understood me to be asking it was just to square this part, just the radical part. If I want to square the whole thing, which is what I'm doing, I'm squaring all of side C, or the length that I think might be my C, I have to put it in parentheses. And that's 50. Okay? So is this bigger, smaller, or the same as what I got for a squared plus b squared? It's the same. 50 is equal to 50. So this is a right triangle. Remember, if c squared is the same as a squared plus b squared, then it's a right triangle. All right. Let's see if I can find a good acute example. Okay, let's do 5.2, 8.9, and 8.1. Are those in order? No, they're not. So be careful of that, remember. This is the largest side, so this would have to be the C. So when I square and add A and B, and it doesn't matter which one's A and which one's B, that never matters. So 5.2 squared plus 8.1 squared. Let me do that in my calculator. 5.2 squared plus 8.1 squared gives me 92.65. 92.65. And then I'm going to do c squared over here. All right, so 8.9. When I square 8.9, I get 79.21. Now I base my decision on this number. Is this number smaller, larger, or the same as what I got for a squared plus b squared? It's smaller. Okay, so since 79.21 is smaller than 92.65, that's acute. So again, when c squared is larger, that's an obtuse triangle. When c squared is the same or equal, it's a right triangle. And if your c squared is smaller than what you got for a squared plus b squared, that's an acute triangle. So as long as you do it in that order, it makes sense to me. Larger goes with obtuse, making all my decisions based on c squared. If I wanted to write that like this, notice well, my pencils are not sharpened well, my colored pencils. I could write it like this, and it pretty much says that if c squared is larger, it's obtuse. If c squared is smaller, it's acute. And these mean the same thing. And these two mean the same thing. And we could rewrite this one too. If c squared is the same, it's right. Hope this helped you with Pythagorean Converse. Now let me point out, if you are not in my class, what we are doing right now is just looking at this. But sometimes when you're done doing questions like this, you're asked first, can these lengths even make a triangle? Okay, and I just realized I used one that can't. Sorry about that. I apologize. Don't worry about that if you're not being asked that. But yes, you are asked, can these lengths be a triangle, period? That's different from Pythagorean Converse. And so I would go check out a video on it's called the Triangle Inequality, to know whether the three sides can even make a triangle. All right, inequality. Look for a video for that. Basically, they're saying with these three segments, like if you have segments that are like this length, they wouldn't touch. There's no way to get these two to touch. They can't even make a triangle. Turns out that any two sides have to just plain add up. Just plain add up, not squaring. Just plain add up as they are to more than the third side. This is the one that doesn't cut it, because 3 plus 4 is not more than 7. So I actually used a poor example here, my bad, because this doesn't actually make a triangle. 3 plus 4 would have to be greater than 7. Equal to does not cut it. Equal to is not good enough. You will notice, though, if you forget to check the ones that can't be a triangle, they always end up coming out to be obtuse. So if you forget to check, that's a hint. Go back and check the ones that came out obtuse.